So when we talk about these current sensors, and you've heard me reference source and simulate on your process meter, simulate is merely adding a resistive load. That means that you already have loop power, or you're already feeding 24 volts to the circuit. So you would feed 24 volts into here, and then this would load a resistive value between here, and the common would go to the PLC input. Now if you don't have 24 volts, you're going to have to add do a source, which when you do a source output here, you're actually generating 24 volts DC, and then you're actually loading the circuit in here, but you're also applying voltage. So let's look at our two different sensors. We have our small one, which is the ACT 10 volt model. Notice that it requires loop power. This means that it will have to be wired into a loop configuration, which means that I should read 24 volt DC on terminal 2 at all times, or this thing will not work. We have the larger size, the the 3 ACT-050 for 50 amp. They're basically all the same. The last part just determines what coil it's been calibrated to. This one, on the other hand, generates its own voltage. So unless this thing is hooked up with 1 amp of current flowing through it, it doesn't have enough internal power to run the circuitry. So it basically is hooked up with differential wiring inputs, as in this wiring diagram. Here we'll see the negative is simply tied to the V/current negative terminal on the card, and the positive goes in there. This is differential. It's expected that that one generates its own 24 volt DC to go along with it. Alternatively, we can do single-ended or loop powered. Here you'll see it's a little different because we jumper the 0 volt to common here, and we either flip the power supply to use an external source, or you can flip a switch inside this card and it will use the internal bus supply. So you may not see this right here, but you're definitely going to see the ground, the reference, the analog common. So you're going to see that analog common probably tied to 0 volts and everything. And so the positive goes into the current transmitter, and then the negative out of the current transmitter goes into the positive current input right here. We were looking at it with this diagram here. Terminal 2 on this diagram would go to the power supply, and then L1, or the signal out, would go to the positive current input right there. So these are basically calibrated like all the other loops we've done. I can't really hook these up and tell you anything about them. You're simply going to follow the other procedures and source and simulate a high and low voltage. What I can do is we can go over our calibration certificates. Here I have a copy of the 300 ACT. Let's zoom in a little bit. Notice that this top one, this has the three-phase model. Of course, you have phase L1, L2, and L3, or A, B, and C. And so you'll have to make sure these are set different for each one, because it's basically 3 analog outputs in 1 sensor. So here's our 50 amp model. What we're going to do, as found, So whenever we wanted to simulate the high end, we would generate a 20.002 milliamp signal into our PLC input, and then we would make sure that the scaled max is set to 50 amps. So that's what we would do here. On the bottom end, we're going to do a 4.002 milliamps. Okay? Now what I will tell you is once you have entered this data, you'll probably notice a slight float right here. So that might be what the 0.002 is, because if it's on the voltage model, you'll see millivolts bleeding off. So once you're done with this, you basically, with no current flowing through the sensor, you need to take the present raw value and put it into the raw min in your calibration application right here. You would take, right now we have a present raw input of 4.001 milliamp. So I would say that that sensor's hooked up, but we're bleeding off a little bit, so I would simply come over here and whatever, remember, you can generate a signal, but we have resistance to the wire, and that's actually floating. Just whatever is here, say that's 0 to 1, so we just put in 4.001 or 4.001 milliamps. And of course, our min scaled value on that model, if we were looking at 50 amp, would be this. And if I'm going back to that sheet, I will see that the max is 20.002. So my calibration application, I would take this 20 point there. And that is basically it. You'll have to update the install date and expire date. You'll need the serial number from the calibration sheet and the gauge number. Should be on the yellow tag. You enter all that and you're done with this. You just have to make sure the wires are put back in precisely the same spot. I would suggest, if possible, to hook up a load to it and test it before production runs. That can be kind of difficult if you don't have a unit in pitch. So, but mainly if you hook it up and you're not floating at your min of 4 milliamps, you're showing anything like 3.2. I mean, 3.2 is basically open. That tells me it's not even powered up. So make sure that when you're done with your hookups to these current systems, that they're still floating at 4 milliamps.